Jai Shri Gurudev. In this particular class, let us talk about the centroid of some of the standard geometrical figures. The first one, let us consider a rectangle. So, in the rectangle, consider over here, the x-axis is going to be over here, followed by the y-axis, and then the centroidal axis is x as well as y have been denoted. Now x bar is this particular distance, that is distance from y axis to y axis, and y bar is going to be from x axis to x axis. The area of the given rectangle, let us consider the breadth to be b, and then let us consider the depth to be d. So area is going to be b into d. X bar is going to be b divided by 2. Y bar is going to be d divided by 2. The second case, let us consider a triangle having breadth b followed by depth or height d. So the area of the triangle is half into b into d, half into base into height. Let us denote the centroidal axis x and then y, the point of centroid, and then let us denote x bar and then y bar distances. If you can see, y axis is a symmetrical axis, that is, it divides the given figure into two equal halves. So this is going to be half of the base, that is b divided by 2. Coming to y bar, this area is going to be more, or the mass of the triangle is going to be concentrated over here more. Hence, this particular distance is going to be 1 by 3 of d, that is nothing but the centroid value. Coming to a right angled triangle, let us denote the x-axis and y-axis to begin with. Now let us mark the centroidal axis x and then y, the centroid. Let us mark x bar and then y bar. X bar, again here the area is going to be more, or the mass is going to be concentrated more, hence this x bar is going to be 1 by 3. Now first let us write the area, half into base into depth, and then let us mark x bar 1 by 3 of, this is the breadth, 1 by 3 of b, and then this is going to be the depth. So this is also going to be 1 by 3 of d. Now coming to a circle, x-axis and y-axis, let us mark them, x-axis, y-axis. Let us mark the centroidal axis, x, y. The radius of this given circle is small r. Now let us write the area of the given circle, pi r square. Now followed by x bar comes over here, y bar comes over here. Can you see that x bar and y bar are nothing but the radius, so I can just write it as r and r. Now coming to semicircle, first let us mark the x-axis and y-axis. Under semicircle we have 4 different ways in which a semicircle can be represented. All the 4 ways are going to have the area same, so that area is nothing but pi r square divided by 2. Now this orientation, based on how it is going to be, x bar value and y bar value are going to vary. First let us denote the x-axis and y-axis. In the first case, x-axis and y-axis is over here. Now let us mark the centroidal axis xx followed by yy. Can you see that yy axis is dividing this given semicircle into two equal half? So radius is nothing but small r over here, and diameter is nothing but d. So this distance that has been marked is x bar, and this distance is going to be y bar. So x bar can be written as radius, or you can also write it as d by 2, half of the diameter, followed by, now the y bar, this particular y bar is going to have a value of 4r by 3 pi. We have derived it in the previous classes, 4r divided by 3 pi. The main thing that has to be remembered is the distance 4r by 3 pi is going to be from this flat base, from the diameter, not from the curved surface. Please remember this, from the base or your diameter itself, the flat surface itself, the distance is going to be 4r divided by 3 pi. Now coming to the second orientation, area remains constant. Let us mark x-axis followed by y-axis. If you can see, y-axis is negative, it is downwards. Now let us mark x-axis, and then let us mark y-axis also over here. The distance, this distance is going to be x bar, and then this distance is going to be y bar. So y axis divides the given semicircle into two equal halves, so it is d divided by 2, and then y bar is going to be 4r by 3 pi with a negative because it is along the negative direction. Coming to the third orientation, let us mark x-axis followed by the y-axis, the x-axis, and then y-axis. This distance is going to be x bar, and then this distance is going to be y bar. Now x-axis is the one that is going to divide the semicircle into two equal half. So first let us write this x bar. Previously I told you that from this diameter, from this flat surface, the distance is going to be 4r by 3 pi. Now the x bar value is 4r divided by 3 pi, whereas the y bar value is going to be d by 2 with a negative sign because the y-axis is along the negative direction. The last case of the semicircle, x-axis is going to be negative, followed by y-axis also, which is going to be negative. This is the x-axis, and then this is the y-axis. Centroid G, this distance is going to be x bar, and then this vertical distance is going to be y bar. So similarly, how we have written x bar as 4r by 3 pi, here also we are going to write it as 4r by 3 pi with a negative sign because it is along negative x-axis, and y bar is going to be d divided by 2 with a negative value because it is going to be along the negative y-axis. Coming to the last one, quarter of a circle. Let us first denote x-axis and y-axis, x-axis and then y-axis. This is the x-axis, this is the y-axis. Now from your origin to x-axis is x bar, origin to y-axis is x bar, origin to x-axis is going to be y bar. So both the distances, if you can see, are going to be equal in this particular case. First let us write the area of the quarter of a circle, which is pi r square divided by 4, and the value of x bar and y bar is going to be 4r divided by 3 pi based on the derivations that we had done in the previous class. Now the thing that has to be remembered is From this point where you have this 90 degree, from this point to your centroidal axis, either along x or along y, the value is constant. It is going to be 4r divided by 3 pi.